Hey, this is Mr. Mitchell with another video. This particular video is about a formula that you may find familiar. This formula here at the bottom is F equals m times a. Force equals mass times acceleration. And that happens to be in one of Newton's three laws, or three claims. This is part of Newton's second law, that force equals mass times acceleration. So what does that mean? Here at the top we have a baseball and a softball. And if you were to take the baseball and the softball and throw them with the exact same force, would they both go at the same rate of acceleration? Newton would say no. Newton would say that the force is equally affected by the mass of the object and the acceleration. So if you have the same force thrown on the baseball, which has a mass of 0.14 kilograms, as you have same force thrown with a softball that has a mass of 0.20 kilograms, then Newton would say that you cannot have the same acceleration. And you know, that kind of makes sense. If I'm working with a formula here and I put, I think I'll just grab a number out of thin air, 5 newtons here for the baseball, and the mass is going to be 0.14 kilograms, multiplied by an acceleration, and you have the same force applied to the softball, which has 0.20 kilograms. If you're going to end up with the same force, if you're going to end up with 5 on both of these, that means the accelerations have to be different if he has a correct claim. So this acceleration for the baseball would have to be more than the acceleration for the softball to equal the 5. And that's kind of where this formula comes from, where this premise comes from. Sorry, I'm making stray marks everywhere. But this applies to anything that has movement, that has acceleration, that is moving faster or consequently moving slower. It's not at a constant speed. You take its mass and you can find out what kind of force you have. Now this can talk about like a shopping cart that is moving in a store. This could be about a bed in bed races. I have heard of bed races happening. You would want a heavier bed to get more force. Lots of different applications to this. Now you're going to have some problems with this. So I just want to kind of do a couple of these to show you a little bit what might some look like that you might end up doing. Here speaking of shopping carts, here we have a 20 kilogram shopping cart accelerates down the grocery aisle at 3 meters per second square. Kilograms is the standard unit for mass. Meters per second square is the standard unit for acceleration. So of course it's asking for the force, and force equals mass times acceleration. So let's find the mass. Force equals, what is that mass? Looks like it is 20 kilograms. So of course you just plug in the 20 kilograms. Please make sure to put the unit there, and that's going to be multiplied times, and I'm just going to put the dot there, 3 meters per second square. You do not have to make any conversions on this particular problem. So 20 times 3 is going to be 60. Now keep in mind you want to keep the units right, meters per second square. So we're going to have 60, and instead of having kilograms times meters per second square, somewhere along the line somebody thought to just have that as a unit for force and name it after Newton. So it's going to be 60 newtons. So if you see the figure Newton, then it is kilograms times meters per second squared. You might actually end up with something like this. You might have a formula where you have to change things around. And here it says Zoe accelerated a lip balm, hadn't thought about that in a while, 1.5 meters per second square using 0.6 newtons of force. So now we're finding the mass, and you see that we have force equals mass times acceleration. You're going to have to isolate the m. Now we've had a video on how to do that. That is a reference video. And if you find out that you're not succeeding very well on this, then you have a reference there. But long story short, you want to isolate the m on one side. Those cancel out, and you can flip it. So you're going to have mass equals force over acceleration. And from at this point, it's just a matter of plugging in numbers. Force is going to be in newtons, so that's going to be 0.6 newtons. Remember, you want to put the unit there. And the acceleration is going to be 1.5 meters per second squared. 1.5 meters per second squared. And this is not one you can do in your head, but I'm going to go to a calculator and complete this. So all I have to do is type in 0.6 divided by 1.5 equals, and that's going to be 0.4. 0.4. And what is the unit we're going to look for? Mass is going to be in kilograms. Mass is going to be in kilograms. So that's an example of the type formulas, the formula and the type problems you will have in Newton's second law, and a little bit about the reasoning behind Newton's second law, or his claim for this second law. We're actually going to use this formula when we talk about gravity, because gravity on Earth has the same rate of acceleration no matter what you're dropping. So you'll see this formula again, except you'll have a constant there for the acceleration. Hope you learned a little bit. Thank you.